Alright guys, I'm back. Got another video here with integration using substitution. So this is still section 6.2. What we've done up to this point so far is we've looked at integration using substitution with indefinite integrals. Okay. What we're going to do today in this video is use definite integrals. Okay, so what we mean by that is we're actually going to have a value. We're going to be able to solve. We're going to get some number, some area under the curve here from 0 to pi over 3. And this is our example of tangent x times secant squared x. Okay, so if you remember, let's start with this example. Now, if you remember, I don't know if I mentioned this, but I'm going to show you two different methods of solving this guy. Okay, using substitution. All right, so two different methods that we can use. So if you remember with substitution, what we have here is we're trying to figure out, we're trying to let u equal some expression that if you take the derivative of it, you're going to get some other expression in this integral. Okay, so with that, I just want you to focus on here. So you guys have a formula page. Okay, here it is again. I know I've showed you this before. I mean, you guys have that, so have that out when you do this. That formula page. Hopefully this refocuses. So, if you look at that formula page, you'll notice, I'm not sure how far down it is, it's under trigonometric formulas. These are all trig functions. If you look at it, it says this: the antiderivative of secant squared of u du is equal to tangent of u. All right, plus c. So, if the antiderivative of secant squared that is tangent, then what would the derivative of tangent be? And hopefully you got it, it's secant squared, okay? So what I'm going to do in this case is I'm going to let u equal tangent, okay? Just tangent x. There we go. Okay, so if we did that, now du is going to be the derivative of tangent x, which is going to be secant squared x dx. Okay, remember when we did that? Really, if I wanted to write this all out, I could write u as the derivative of u as du over dx, but then I want to solve for du, so I need to multiply both sides by dx. Okay, so we get secant squared dx. All right, so let's keep going. Now, this, like I said, this is the first method, so here's method 1. Okay, on the next slide, I'll have method 2. All right, we'll look at two different ways of approaching this. So method 1 is to write your integral. So, guys, we're still going to have, we want to write the integral from 0 to pi over 3, but remember, these are x values, okay? So, I'm going to kind of, what do I want to say here? I'm still going to write these, with method 1, I'm still going to write those x values, but I need to denote that they're x values because this just becomes, now we said u is equal to tangent of x, so it's going to be the same thing as u times this guy right here. Isn't this guy du? So let me point this out. This is u. And isn't that whole thing du? Everybody agree? Okay. So I'm rewriting this expression. Okay. I'm rewriting as u du. All right. Hopefully that makes sense. So here we go. Let me write this down. It's going to be u du. But then, guys, like I've been mentioning, these two values are x values. So we still have to denote that they're x values. They're not u values. Okay? So if I wanted to denote that they're x values, this is going to be x equals 0 and x equals pi over 3. So guys, I know I'm not going to be able to plug those in for u. I will be able to at the end when we figure out our antiderivative. Once we figure that out, we will be able to plug those in when we plug in x. All right? So when we replace u with tangent of x, we're going to be able to plug those in for x. We cannot plug those values in for u, all right, because these are x values. Now, this is just the first method that I'm trying to explain. The next method will be a little different. Hopefully, you guys will see the difference. Okay, so here we go. If I just want to take the antiderivative of u, well, that's just a polynomial function. What do we do to the function? Well, we got to add 1 to the exponent and divide by the new exponent. So this is u to the first. So if I add 1 to the exponent, it's going to be u squared. I got to divide by the new exponent, which is 2. Okay? So it's just u squared over 2. And I'm going to evaluate that from x equals 0 to x equals pi over 3. All right, so now, again, I can't use, normally what we would do from here is do f of b minus f of a. All right, but I can't do that yet because I can't plug in x equals pi over 3. We have to have a u value here to plug in there. So what I could do is I could replace u squared with whatever we let u equal. Well, isn't u equal to tangent of x? Okay, so let's just replace u with tangent of x. So this is going to be tangent square of x over 2, evaluated from 0 to pi over 3. Now notice what I did here. I got rid of my x equals. We know they're x values. These are the values I'm going to be able to plug in. If you want to keep it written as x equals pi over 3 and x equals 0, you can. But since I know I now have x values and I can plug in, I can just leave them from 0 to pi over 3 like we usually write them. Okay, so guys, just to recap here, since we replace this with u, we have to remember that these are x values. Okay, now like I said, this is method 1. We're going to look at it a different way in a second. All right, a different way to evaluate. So all we got to do now is use the fundamental theorem of calculus part 2. Sorry. So it's going to be f of b minus f of a. All right, so this is going to be tangent squared of pi over 3 over 2 minus tangent squared of 0 over 2. All right, so let's try to figure those values out. Now, to figure these out, guys, you're going to have to use your unit circle. Okay, so let me bring that up real quick. Remember when we did this in advanced math? Okay, don't forget your unit circle here. I tell you what, I'll probably print one of these out and leave it for your sub to give to you, so you can look at it. You probably have one in your notebook. So here we go. Let me bring up your unit circle. All right, so here it is, and we're trying to look at pi over 3. Okay, so that point right there, pi over 3. So the question is, tangent, we're going to do tangent square, but let's just figure out tangent first and then we'll square it. Okay, so what is the tangent of pi over 3? Well, let's go back to it. Just off to the side here, essentially what I'm trying to do is figure out what the tangent of pi over 3 is. Well, guys, tangent is always sine over cosine, so let's write that down. So what is the sine of pi over 3? Well, sine deals with y values. So what is the y value of this point going to be? Is that my smallest y value, my middle y value, my biggest y value? And everybody should know it's my biggest y value. So the sine of pi over 3 is going to be the biggest important value we have to choose from, which is square root of 3 over 2. Okay, this should be a review from advanced math. All right, trig. Let's keep it going. Now, the cosine is essentially, well, if the sine was the biggest value, think about your x value here. Cosine deals with x values. So is that my smallest, middle, or biggest x value? It's going to be the smallest important value, so therefore it's 1/2. So I've got the square root of 3 over 2 divided by 1/2. If I, instead of dividing by that fraction, 1/2, I could always multiply by the reciprocal. So what's the reciprocal of 1/2? Yep, that's 2. So I got to flip that and multiply. It's the same thing as multiplied by 2 over 1. So instead of doing that, I'm choosing to do this. And what's going to cancel here? 2 divided by 2, those cancel. And so what we're left with is the square root of 3. All right, so that's what the tangent of pi over 3 is. Okay, so let's plug that in. So this is the same thing as the square root of 3 squared over 2 minus, now let's just do tangent of 0 really quickly. I don't have to write this down. So remember, tangent sine over cosine. So what is the y value of this point at 0? 0 degrees or 0 radians. What's the y value? Answer is 0. Okay. Now what is the x value at that point? 1. So what's 0 divided by 1? Well, the answer is 0. So guys, this will be 0 over 2. Or you can say 0 squared over 2 if you wanted to. But we know what that's going to be. This whole thing's going to be 0, right? So what is the square root of 3 squared divided by 2? The square root of 3 squared is going to be 3. So it's 3 over, whoops. Not bad. 3 over 2. There it is. So that's my answer. Now, I told you I was going to show you 2 methods. So if you like it that way, do it that way. Okay? If you don't, here's another method. So guys, again, let me recap the method we did there before I move on. Okay? So I just did substitution like we've been doing. All right, we use substitution still. We're still working with that. Now, with definite integrals, we need to make sure that if we use substitution that we know what values we're talking about. So these are still x values, so we can't plug those in for u. We can plug them in for x though. So what we did was we took the antiderivative. Okay, once we took the antiderivative, I noticed there's still x values, so I can't plug those in yet. I have to replace u with what we let it equal. So we said u was the tangent of x. Okay, so this is going to be tangent squared of x. Now we can go and plug those in. Okay, let me show you another method. All right, so here goes. It's not much different, guys. It's basically the same thing. So I'm just going to run through this real quick. Since we've already done it, it shouldn't take us that long. So here we go. Again, it's the same thing. We're going to let u equal tangent of x, just like we did last time. And so du is going to equal secant squared of x dx. Okay, so this is, again, going to be u times du. All right. But before, let me rewrite this. It's going to be the integral. Now, instead of writing it as x equals 0 and x equals pi over 3 like we did last time, what if we wanted to go ahead and figure out what those values were in terms of u values? Okay, so what I mean by that is I can figure out, let's just say this is a function like u of x. All right, what if we said u of 0? Okay, if we want to figure out what the u of 0 is. Well, that's the same thing as tangent of 0. Okay? So if our x value is 0, we can figure out what our u value is going to be if we just plug it in here. So guys, if I plug in a 0 there, it'll give me a u value, right? Okay? If I plug in a pi over 3, it'll give me a u value. So I can figure out what those are first and then try to work on it. So here we go. We already found the tangent of 0 is 0, right? And then we could also find u of pi over 3. We've already found that. We found that last time. So that it'd be the tangent of pi over 3, which is, we would say, what, square root of 3? Okay, so we can rewrite this interval. Instead of saying it's x equals 0 to x equals pi over 3, we can write it as just from 0 to the square root of 3. All right, so let me go back here and let me show you the difference. So instead of writing it like this, x equals 0 and x equals pi over 3, we found our u values. Okay, so that's what we're doing here. We found u values, and we can just integrate with respect to those. Okay, that's my new integral. Or sorry, it's my new integral. That's a u interval. All right, so this is going to be u du still. Well, it'll still be the same type of concept. We got to take the antiderivative of it, don't we? So the antiderivative is still the same. It's u squared over 2. Instead of evaluated from x equals 0 to x equals pi over 3, now it's going to be evaluated from 0 to square root of 3. Okay? So we still use the fundamental theorem of calculus part 2. So f of b minus f of a. And so it's going to be f of the square root of 3 minus f of 0. And if we plug in the square root of 3, it's going to be square root of 3 squared over 2 minus 0 squared over 2. Well, that's the same thing, guys. It's still going to be 3 halves. Okay. So pause it, rewind it if you need to there. Kind of went through that really quickly. But no matter which way you choose to do it, you get the same answer. So you can do it either one of those ways. Now, they're pretty similar. There's not a whole lot of difference between them. It's up to you how you want to solve those. Okay, so you can substitute your u in up here first, or you can wait to the end here and substitute your tangent of x back in. So, yeah, either way, whatever you prefer is what I'll say. Okay, so if you want to integrate method 1, go ahead. Method 2, whichever one you prefer. Okay, so whichever one makes more sense to you. So yeah, I'm going to do more of these, but I think for this video, I'm going to call that a video right there. We're just going to work on more examples here. I'll do it the way I prefer it with these next examples. Okay, thanks.